Okay, so here's some more information on the conditional. We're going to cover what it is to be the converse, the inverse, and the contrapositive of something. Look at some alternative forms of if P then Q. Look at biconditionals, which are if and only ifs, and summarize some truth tables. So let's put it all together so we can see it visually. Our typical conditional statement, right? If P then Q. The converse just goes in the opposite direction. So if Q then P. The inverse is just both things inverted, right? So not P and then not Q. And then the contrapositive is like a double inverse, right? It's the converse and the inverse put together. So the direction changes. Now we've got Q going to P, but then we've also made inverses of them both. So it's if not Q, then not P. Some examples. If we use the statement, if I live in Wisconsin, then I shovel snow, we can do the converse, the inverse, and the contrapositive. Again, the best thing to do with these things is to identify the pieces. If I live in Wisconsin, right? So I live in Wisconsin is P. Then I shovel snow is Q. So there's my P implies Q. The converse, remember the converse just goes in the other direction. So it's if I shovel snow, then I live in Wisconsin. There's Q implies P. The inverse, remember, is same direction, but everything is opposite. So if I don't live in Wisconsin, then I don't shovel snow. So all we've done is make both of these negations. And then the contrapositive is you negate things and flip the direction. So we want not Q, right? If I don't shovel snow, then not P, then I don't live in Wisconsin. A conditional statement and its contrapositive are equivalent, and the converse and inverse are equivalent. If you don't believe me, make a truth table and convince yourself. P, Q, true, true, false, false, right? True, false, true, false. We can do P implies Q, Q implies P, not P implies not Q, and of course not Q implies not P. Remember that conditionals, and no matter what form they are, these are all still conditionals. They just have special names, right? This is still something, then something, right? If something, then something else. And the rule for those is the only time they're false is when the first piece is true and the second piece is false. So true, false, true, true. Well, now this is only going to be false when Q is true and P is false. So that's down here. And this is true, true, and true. Okay? This thing, right, just like everything else, is only false when the first thing is true and the second thing is false. So the first thing is true. We'll put a color on it. So we want to know when that thing is true. Well, that thing is true when P is false. Okay? And then if the second thing is false, well, the second thing is false when Q is true, right? So that would be this one or this one. And we can see that's the only one where they match up. So there's false and then true, true, true. Okay, and then we'll do the same thing here. This thing has to be true, which means Q has to be false. And then this thing has to be false, which means this thing has to be true, right? P has to be true, and they match up there with the second one. So that's false, whereas everything else is true. Can you see how these two are the same, and then these two are the same? So the conditional and the contrapositive are equivalent. and then converse and inverse are equivalent. Alternative forms of if P and then Q. It's just basically a bunch of verbiage, a bunch of English that says the same thing. If P then Q is the same thing to say P is sufficient for Q. So P is sufficient for Q to happen. And then if P then Q is the same thing as Q is necessary for P. P implies Q is all P or Q, and if P, or sorry, P only if Q means Q if P. Again, just put it in your notes. I wouldn't worry about them too much. Okay, write each statement in the form if P then Q. So you'll be sorry if I go. Well, do you see how you'll be sorry if I go means if I go, then you'll be sorry? Today is Sunday only if, right, yesterday was Saturday. So if yesterday was Saturday, then today is Sunday. Or if today is Sunday, then yesterday was Saturday. I mean, you could really do that either way. And then all chemists wear lab coats. That means, and if we look back up here, all chemists wear lab coats. All P are Q, right? So all chemists wear lab coats means P implies Q, means if you are a chemist, then you wear a lab coat, okay? Biconditionals is just a conditional in both directions. We normally use a double kind of sided arrow. Sometimes we use IFF for if and only if, a shorthand for it. And it basically just means P implies Q and at the exact same time Q implies P. So they both imply each other. And remember, conditionals are only true, or sorry, conditionals are only false when the first thing is true and the second thing is false. So this first thing is false only if we have true false. And this thing is false, again, only if we have true false. And remember, we have an and, which means they both have to be true. So they're true in all the other cases. And if we look at it, the only two cases that are left are if they're both true or if they're both false. So if we put that into a table, we can see that if and only if statements are true whenever both pieces have the same thing. So they're both true or they're both false. If they're opposites, then the whole thing falls apart because then one of the halves, right, is false. And because it's an and, if either half is false, the whole thing is. Because it's an if and the other if, right? If and only if. There's an and in there. Determine whether each biconditional statement is true or false. So 5 plus 2 equals 7, if and only if 3 plus 2 equals 5. Well, 7 equals 7, that's true. 5 equals 5, that's also true. So true if and only if true means the whole thing is true, right? 3 equals 7, that's false. If and only if 4 equals 4, that's true. But remember, if and only ifs, you can't have opposite signs, so that's false, okay? 7 plus 6 is 13, so this is false. 9 plus 7 is 16, this is false. And false, if and only if false, means the whole thing is true. True, false, true. Lastly, to summarize all of these things, we know that the negation of a statement has true values that are opposite of the original statement, right? Whenever the first statement is true, the negation is false, and whenever the first original statement is false, of course, the negation is true. The conjunction, remember, conjunction is an and, right? So conjunction is just the fancy word for the and symbol, and that is true only when both statements are true. Remember, if either statement is false, the whole thing is false. And then disjunction means or, and that's only false when both statements are false, right? So the first one, the conjunction, is almost always false, and the second one is almost always true, right? They both just have one case where they're one thing, right? So the conjunction is true only once, the disjunction is false only once. And then the biconditional, the thing that goes in both directions, right? Biconditional, is true only when both statements have the same value. So they're both true or both false. So there's a summary of all of those things.